Hello, good evening all. In this class, we'll discuss about the gyroscope. So basically, a gyroscope is a device which is used for measuring and maintaining the orientation and angular velocity. Okay, so it is one kind of disc, okay, which has axis of rotation, then gyroscopic axis and axis of precession. When we are rotating this axis, okay, now that disc will going to tilt about the precession part, and this is one kind of compass, gyro compass, which is used in ships, aircraft, spacecraft vehicle, and it assists the stability of these bicycles, motorcycle, and ships part. Okay. Now, basically, gyroscope based on other operating principles also exist, such as maps by gyroscope found in electronic devices. Now, gyroscope applications of inertial navigation systems such as Hubble telescope for inside the still hull or submerged submarine. Okay. Now, if you look at the arrangement, so we have precession axis, gyroscopic axis, and spinning axis. So this is the axis about which that disc will get spin. Now suppose if you take example of propeller shaft of aeroplane, okay. Now it has two motions. One is clockwise motion, second is anti-clockwise motion. So we need to identify the direction of active and reactive gyroscopic couple based on this rotation. We have one more part, gyroscopic axis, about which we are turning that. Suppose if you are taking plane towards right side or left side, we need to identify what is active couple and reactive couple acting on that plane. And there is one more part of precession. So it is the axis about which that particular plane is going to twist, or that disc will going to rotate. That axis is nothing but axis of precession. And we have these three plane of precession, which is perpendicular to gyroscopic plane and spinning plane. Then we have plane of gyroscopic couple and plane of spinning couple. Now one by one we'll discuss how these axes are defined. Okay. Now axis of spin, it is the axis about which that propeller shaft or body will get revolves. Gyroscopic axis means it is the axis about which that is perpendicular to this precession and spinning axis. And this impact of active and reactive couple we are identifying on the gyroscopic axis. Then third we have precession. So it is the rotation about third axis y, which is perpendicular to both spin axis and couple axis. Now axis of precession is nothing but about which we are just turning that particular system, or plane or ship or bicycle. Okay. Now this mechanical gyroscope is defined. It is just simple device which is to control angular motion of body. Okay. Based on this, we can identify how much gyroscopic couple acting on that particular system. That value we can calculate with the help of that gyroscopic couple. Okay. Now look at the movement of system, how that system is moving. Okay. Now first, we need to identify how we are deriving that data, how we can determine the various components available in the gyroscopic axis. So we have angular acceleration. Okay. Now just look at the disk. The disk is rotating about this axis. Okay. Now omega is angular velocity of disk. Now rate of change of that velocity will be omega plus delta omega. Theta is the angular displacement about which we are providing the movement for that disk when it is rotating. It will get tilted by some displacement, angular displacement, that is delta theta. Now if I write Ox, that is by changing the limit with respect to time, delta t is to 0. So you can write omega del omega cos del theta minus omega del theta. Now, what is this dt? Dt is the but rate of change of displacement, angular displacement with respect to time. Okay, so we are calculating that uh, angular acceleration about Ox. So this is the initial value. Omega is initial value, and rate of change of displacement will be omega plus delta omega, that we are defining with respect to theta and time. Now by putting this omega cos delta theta plus delta omega cos theta minus omega delta theta, again we are taking cos theta is very smaller term, so it is equal to 1. So you get that value del d omega upon dt. So acceleration will be d omega, rate of change of angular velocity with respect to time. That is nothing but your angular acceleration. Okay. Now next, to get that acceleration value, again we can define with respect to time. So omega dou omega sine delta theta, that is perpendicular to Ox. If we take gyroscopic acceleration perpendicular to Ox, so again it will be omega delta theta plus del omega delta theta upon dt. So this again delta omega and delta theta are very small terms, so we can neglect this. So acceleration will be omega into omega b. That term value we have. Okay. Now look at the axis. We have axis of spin, axis of gyroscopic couple, axis of precession, and we are providing forward clockwise, anti-clockwise, and clockwise motion. So if you look at the right hand thumb rule, so if observer is looking from this side, this rotation is nothing but anti-clockwise rotation for that aeroplane. Okay, so by looking from front side, we'll get this axis of spinning axis by applying right hand thumb rule. So this is front end and tail end position of that plane, and this is observer position, which is looking from front. So there are two options: either observer can look from front and rear end on that plane, and based on that, we can measure the values of gyroscopic couple acting on a plane. So this is the first position where that rotor rotates in anti-clockwise direction. We have one more part when rotor rotates in clockwise direction. Just look at the position of plane. So nose end will be at nose end towards the observer. In previous case, the nose end was away from the observer. Okay. When we are taking anti-clockwise direction, in this case, nose end is towards the observer. When we are looking a clockwise direction, again look at the right hand thumb position when that propeller rotates in clockwise direction. Okay. Only we have to rotate thumb towards right and left position to get the value of active and reactive gyroscopic couple. Okay. So this is all about axis of spinning. Now next part we have, this is axis of spinning. Then we have axis of precession. Okay. Now in axis of precession, again we have clockwise and anti-clockwise movement. Again, this axis of precession is perpendicular to spin and gyroscopic axis, about which we are just shifting that plane towards left and right side. Suppose say if the rotor rotates in clockwise direction, just look at the movement. Okay, so this is the movement of that particular plane. If rotor rotates in anti-clockwise direction, okay, and we are turning that plane towards left and right position, and this is the clockwise position where we are again finding the active and reactive couple, okay, value by just moving that part spinning axis about gyroscopic axis towards right and left side. Okay, and we have third part axis of precession, axis of spin, and we have third part is gyroscopic axis. Okay, just look at the third part, gyroscopic axis. Again, just we are turning that part towards left and right side. Suppose the rotor rotates in clockwise direction, and if we are turning that thumb towards right side, this is the position of that plate. So T, uh, so it's you can say tail end will get raised, and that deep part nose will goes towards downside, and tail will goes in upward direction. When we are talking about this gyroscopic axis, okay, and in second case, nose will get raised and that tail will go down when we are rotating clockwise direction, and it is moving at left side. Okay. Now look at the data. How we will get the calculation part of this gyroscopic axis by taking I omega p value. Okay. So we have discussed that rate of change of angular velocity is nothing but angular acceleration. Okay. And we are talking about this omega, delta omega. Delta theta is the rate of change of angular displacement for that disk, and we are rotating that disk about uh, precision part. Okay. And based on this rotation of the disk, we have I moment of inertia and omega, angular velocity of the disk. Okay. Now to calculate the value of gyroscopic couple, we have taken limit of that delta t theta by delta t, that is the rate of change of angular displacement with respect to time. That is nothing but your angular velocity of precession. So by putting all these, we have I omega p, whereas omega p is angular velocity of precession, omega is your angular velocity of disk, and I is moment of inertia mk square. Okay. So this is all about how one can find out the gyroscopic couple acting on component dot system. Okay. Now just look at the arrangement. So I think we'll stop here. And next class we'll discuss about in detail how that impact is going to happen for gyroscopic couple when there are four different positions of rotors are there in a system, and how one can find out the value of gyroscopic couple when that rotor rotates in different direction. That value we can calculate. So thank you all.